All right, here's 4-6. We're just going to do one day. There'll be a few examples to get through because we're going to cover a lot, but I don't think we need two separate lessons to do it. In section 5, we looked really closely at the sine and cosine curves, sine and cosine functions, right, and their graphs, I should say. There's 4 other trig functions we'd like to take a look at what their graphs look like. We won't get nearly as into it as we did with sine and cosine, but we just kind of want to take more of a basic look at the other 4, starting with tangent. Okay, let's go to our unit circle over here, and we don't need, we'll take kind of the same approach with sine and cosine, that we don't need a ton. We just need some basic values to get going, right? And I'm going to draw in all these x and y coordinates. Okay. All 4 graphs, but I should say them by name. Tangent, cotangent, secant, and cosecant are the other 4 that we're going to look at. They all have points where they will be undefined. We haven't seen that, but with sine and cosine, that didn't happen. Okay, so that's kind of the first thing I'm after. So a reminder, that's our tangent ratio. It doesn't happen at the first point. If we're at 0 radians, tangent is 0, so that point is going to be on the graph. If you went to pi over 4, right, that was an interesting little spot. We didn't look at pi over 4 when we were building the sine or the cosine graph, but here's a good one to see because tangent is 1. Now I get to pi over 2, and we see that case that we're looking for, right? When you have graphs where it's undefined, you get vertical asymptotes, and we haven't seen this since chapter 2 when we looked at rational functions. But if you're like constructing a graph that has these asymptotes, it's very helpful to know where they are when you're building the graph. Okay? So what I'm going to do now is draw this in, just a vertical dashed line, same as we've used before, and then down at the bottom, I want that labeled that is at pi over 2. Okay? That's at pi over 2. I'm going to jump down to here. Okay? Down to 3 pi over 2. Because what I'm now interested in is when is that going to happen again? All of these graphs are just like sine and cosine in the sense that they're periodic. We should expect to see the same pattern repeat. So I'm going to see another asymptote. Where is it going to be? Well, I go to that next spot where x is 0, and it would be at 3 pi over 2. Okay? Now this leads us to a really, really important property of the tangent function. Because it has some differences. It has a lot of differences, actually, from sine and cosine. Those graphs always had a period of 2 pi. This one always has a period of just pi. Okay? But for tangent and cotangent, for that matter, if you're thinking about its period, think about the distance between the asymptotes. Okay? So now if I wanted to go to the negative side, I could draw in another asymptote over here. And if I go to pi over 2 and then take away pi, I would get negative pi over 2, and there's going to be an asymptote there. Okay? Not to mention right here, if I were at negative pi over 4, there, tangent would be negative 1. Okay? And I would be left with that. Now, if you had gotten that far on your own, I would expect what you would probably do is you would have that. You would connect those 3 points. Okay? But remember, use the asymptotes to your advantage. they constantly approach them. So the tangent function ends up looking like that, and then it approaches that asymptote down there. Once we get past pi over 2, starts over, and then away it goes. There's 2 periods of the tangent graph. All right, in these slides, we've got a couple basic transformations. And again, with these other, so this is good just to be clear for like testing purposes. You could get any one of the 6 trig functions to graph. If you get a sine or cosine, you should expect quite a bit in the way of transformations. Okay? These other 4, will we do transformations? Absolutely. Not to the same extent. I'm not going to give you one that's got like 3 or 4. It's typically just going to be 1 or 2. All right? And here's how you'd want to go about it. Here you can see B is a half. Okay? But this whole asymptote thing, we take a really different approach. The period has changed, but the huge thing that means on a tangent graph is the asymptotes have moved. Okay? And as far as the accuracy of our tangent graph, that's what I want you to be pretty particular about, is where are they? Here, if you multiply both sides by 2, well, there you go. Okay? Taking what's in those parentheses and setting it equal to pi over 2 and solving, you're going to figure out where they are. Okay? So now, I'm going right here. And there's pi. Okay, and it hasn't been shifted from side to side. So over here, as you might imagine, there is negative pi. Okay, and now once I have that, I can just sketch in. And I'm okay if you don't do specific points. What I really want to say is that distinct tangent curve, but I need the asymptotes to be labeled and that you showed the work of where those are. Okay? Now, the other thing to factor in with this one is it does have a period change. Okay? That is something you should be aware of because you could be asked on a tangent graph as to what it is. As always, look to the distance between your asymptotes with a tangent graph. That'll tell you what it is. Here you can see they're 2 pi apart. So if I want to go out here and add another one, I add 2 pi, and that next asymptote is at 3 pi. And there is the second period of that tangent graph. All right, here's another tangent graph. This will be the last one we'll do, and then we'll move on to cotangent. Same approach. Look at what I've got inside those parentheses. Asymptote would be at pi over 2, but I'm pretty certain it's moved. Divide both sides by 2, and you would get pi over 2 divided by 2. And it would be at pi over 4. So now these have gotten a little bit closer to the center. And I can hop over here on the negative side, and there's going to be one at negative pi over 4. Okay. Let's go out and do one more this way. And this can always be a little bit tricky because it's where you have to pay attention to your period. Which again goes back to how far apart are your asymptotes. Negative pi over 4 to pi over 4 is pi over 2. Okay, so if I wanted to get this one, then I would take pi over 4. I just need to add pi over 2. If you get a common denominator and did that, you'd see it's at 3 pi over 4. Okay? Now notice the negative sign. This tangent graph is going to be reflected. And you might be thinking, what about the 3? Isn't that the amplitude? it would make this graph skinnier. Okay, we've seen that number do that to other functions. It doesn't have the really distinct effect that it had with sine and cosine because the sine and cosine curves change directions. Okay, and this graph doesn't. With that negative sign, this graph is decreasing all the time. The only time it's sort of increasing is as we cross the asymptotes. It jumps from a super negative number up to a positive number. But these don't do that, so you don't have that element of how high it goes or how low it goes that we did have with sine and cosine. All right, let's move on. Let's talk about the cotangent curve. We got these other three, and I'm just going to do one example of each. I want to take a similar approach, right, and remind us here that to kind of build the cotangent graph a little bit. X over y, so really now, right off the bat, as we go around the unit circle, that's what we're looking for. Okay, where does this graph have a y value that's 0? Because that's now our concern in terms of where it's going to be undefined. So what you should expect as we build this cotangent graph is to have a couple differences and then a couple similarities. Like you see right here, right at 0, we see that y is 0. Okay. With tangent, those asymptotes were at negative pi over 2 and pi over 2, and now you can see that's not going to be the case. These asymptotes are going to be in different spots. You go up to pi over 2, you get 0 and 1, so there it's just 0. I head out to pi, and there my y-coordinate is 0 again, and I get a second asymptote. At this point, I'm able to talk about the period because I have the distance in between them. Notice that's the same. The period is still just pi, but they're in different spots, okay? And what I want to do now is look at these other two pi over 4 and 3 pi over 4, because those always come out to be nice, okay? At pi over 4, cotangent is 1. At 3 pi over 4, cotangent is negative 1. So then look what happens. It has a really similar shape to the tangent graph, but it goes the other way. Okay, I could go, and once you have one period drawn with all the details, it's pretty easy to just add additional periods. This one over here has to be at negative pi. Okay, now I can see the two asymptotes that it's going to be in between, and a cotangent curve is going to have that shape to it. Looks really similar. The major difference, if there's no transformations, the tangent curve is always increasing. The cotangent curve is always decreasing. This one looks a lot like the last one we did because that was a negative tangent graph. This is just a regular cotangent. All right, let's just do, and again, at this point, let's just do one of each. All right, exact same approach we had before. This graph has asymptotes. Where are they? Notice the difference here. I didn't set it equal to pi over 2 because I've got a cotangent curve. I set it equal to pi. I multiplied both sides by 3, and I get 3 pi. So we've got our 1 at 0. We've got our 1 at 3 pi. And we could do one. Let's do a third period with this one. Once you've got one, they're really not too bad. Okay, if we keep going with the period being 3 pi, that next asymptote would be at 6 pi. So that 2 is going to make the graph skinnier, which we, obviously factor that in. You should see a curve that's a little bit taller and skinnier than the regular cotangent graph. But once you've got those asymptotes, those should be accurately drawn and accurately labeled. From there, I'm just looking to see that distinct cotangent curve. And the problem will say how many asymptotes that you should draw. All right, these last two, things get a little bit interesting. Okay. The reciprocal ratios. Big thing to factor in. I'm not going to go to the unit circle and build it that way. That would be just a bad idea. Okay? Rather, what I want you to see here is secant is the reciprocal of cosine. Okay? Now, this example is going to be a little bit weird, but the good thing is going to be that you're not going to see a real big difference between drawing a secant graph and a cosecant. We kind of go about it the same way. Okay? I'm going to go out to 4 pi. I'm actually going to sketch a graph here, and I hope you can figure out which it is that I'm doing. Because it's not a new one, and it's not going to be all that accurate either. If you need to, maybe pause and think about it for a minute. Okay? It happens to be 2 periods of the cosine curve. The regular old cosine curve. Okay? Now you might be like, aren't we supposed to be learning how to draw a secant graph? That's where you need to start. Okay? It's going to be really hard to draw the secant graph without drawing in the cosine graph first. Okay? Because here's what's going on with this whole reciprocal thing. If you're talking about cosine, cosine is defined to be x over r. Secant is r over x. It flips, right? So basically what we're going to do is take everything on this graph and it just kind of gets flipped. I start with the zeros. If you're talking about the cosine curve, that means x was 0. Notice it's on the top. If you flip it and you're talking about the secant curve, that x is now down on the bottom, and those aren't zeros anymore. Those now become asymptotes. So really important to note here, what I'm sketching in blue is now the actual secant graph. Everywhere I drew a 0, I'm drawing in a vertical asymptote. It's got a bunch of them, and at this point, you could, in reality, you could figure out where those are. If you're sketching a secant graph, I'm not that concerned with them being labeled, just because there's a lot going on with it. Okay, now in between each asymptote, okay, I'm going to start right here. Notice how you have like a little U opening up. Your secant graph would have a little U opening down. Should have a mirror image here. And a mirror image there. Here we kind of get half of one. And there we kind of get half of one. Now you kind of got to look close, but what's in blue is the secant graph with those asymptotes and kind of those U's that go in opposite directions. Okay? On a quiz or a test, even on your homework, just think of the test in particular. If you were asked to sketch a secant graph, you might be wondering, should we sketch the cosine curve first? I am totally expecting that you would sketch the cosine curve first, and then you would fill in the secant graph. And again, for now, we might get more particular with it as we get closer to the test. But as far as like labeling those asymptotes, tangent and cotangent, we're going to be really particular that you know where they are. Here, I'm not that concerned about it. Okay, so here is 2 secant of x. Okay? So right off the bat, I'm going to do 1 period on each side. Okay, and I'm going to start in red here. I'm going to go out to pi. I'm going to go over to negative pi. I'm going to go up to 1, down to negative 1. And I'm just going to sketch right away here. There we go. And there we go. You might be thinking, oh, that's great. What is that? Okay, I want 2 periods total, 1 on each side. Notice here that b is 2. And as a result, our period is pi, but I did 2 of them. Remember, I'm starting with the cosine curve. So literally, when I saw that, I'm like, all right, if I'm going to sketch secant of 2x, what I should really do is sketch cosine of 2x. That's what I should do. Okay? Because now all the references I need are on there. All right, I start with that 0. But for secant, that's not going to be a 0. It's going to be an asymptote. There's another one right there. Another one right there. And one more right there. And once you've got those on there, it's kind of the same process. Flip it. Flip it. Flip it again. And kind of a half of one there. And a half of one there. Okay? Notice the work really was actually here. Draw a decent little sketch of cosine of 2x. Okay? So now, if we get to a point where we're going to be a little bit more picky about the asymptotes, okay, the approach you should take is think about them, you know, if you were to try to figure out, you know, right here, where is that 0? Okay? Where is that 0? This minimum down here is at pi over 2. So that 0 ends up being at 3 pi over 4. Okay? That's where you would want to identify them. Whatever detail you're going to have on your secant graph, take care of it as you're graphing cosine of 2x. All right, last 2 slides here. There's not a whole heck of a lot that's different, right? And honestly, there's really nothing new to talk about other than one little detail. I'm going to start with the sketch that I'm going to make to get started. I'm going to go to 1, down to negative 1. I want to do 2 periods, so I'm going to go out to 4 pi. And we start in the middle. Up again, and down, and back. Okay. Hopefully you figured out what I was up to. Same approach. Now it's a cosecant graph, so the place that we should start is draw a nice sine curve. Okay? Now here I'll get a little bit more accurate with the asymptotes, just because these are pretty easy to see. They can get really hard to identify, but, you know, there's 1 at x equals 0. There is 1 at pi. There's another one at 2 pi. Three pi, and then we'll finish it off with one more asymptote at 4 pi. Okay, so again, what's in blue now is the cosecant graph. And once you've got those asymptotes drawn, flip it, flip it, again, and flip it one more time. And there you go. There's the cosecant graph, right? The only difference is we're going to start with a sine curve. But that's about it. That's it. I mean, as far as like the zeros lining up to the asymptotes and flipping the graph, that's all the same. Now let's finish with this one. Got a couple transformations here. This is probably the trickiest graph we've seen today. I'm just going to do one period. Okay. Now right off the bat, like remember with, even though there's like a couple transformations going on, I'm starting with sine. I'm going to sketch the actual sine curve. So what I see right away there is this needs to go up to 2 and down to -2. And I wanted to come back to this because we saw this in the second day of 4-5. This is a horizontal shift pi over 4 to the left. Okay, and that's a huge, huge number because that tells me where to start. Okay, and that's a big thing, right? My first period, I'm just going to sketch one period for this curve. Okay, but that's where it's going to start. Now the question becomes, where is it going to end? Well, it typically would be 2 pi, right? You can take the approach kind of all those quadrant points, not the quadrant points, but as we would break it up into quarters, pi over 2, pi, 3 pi over 2, all of those get shifted pi over 4 to the left. So what I would want to see clearly labeled on this graph is this ending point of the first period. You should be able to identify that that's right at 7 pi over 4. Okay? Right halfway in the middle, by the way, would be 3 pi over 4. Okay? I'm going to leave those right at that. Okay? That's going to be enough detail. My sine curve is going to start here, peak at 2, come back to 0, bottom out at -2, and then head up to to 0 and finish up at 7 pi over 4. I didn't mark those. I didn't want the graph to get too cluttered, but that would be at pi over 4 and then 5 pi over 4 is where it would hit the max and min. Okay, however, the ones I really want labeled are my zeros because I've got all my asymptotes on there. There, and there. Now, again, what's in blue, this is a cosecant graph. And in between those asymptotes, flip that. I'm just doing one period, so I've just got those two chunks of the graph to flip. And there, again, what's in blue, that is our cosecant graph.